Hello everyone, this is Vivian. I'll be explaining to you the ninth experiment in a Unix lab today. So basically the ninth experiment is all about inter-process communication using pipes. So basically there are two parts of this experiment. So first is using name pipes, where we create a pipe. So I'll just show you the coding. So this is the code. So we give it as I've initialized a few things over here, int fd, and I given the fd size as 2, and bytes id, and so on. Character string is 100, rb is 100. So when I give it as id is equal to pipe fd, and if id is equals 0, so that means the pipe is created, else it's not created. So I'll print the parent process, and I'll print the parent process as get PID, and I'll get the string from the user. So I'll enter the string printf, and I'll use scanner class scanf and read that string. And if child PID is equal to fork is equal to 0, so I'll print the child process and parent process. So for child is get PID, for the parent is get PPID. So the next part, what I'm doing is I'm converting all the vowels of the string I've entered into uppercase letters. So this is the syntax for that. N bytes is equal to read fd0 and rb, comma size of rb. So next I put it in a for loop. For I is equal to 0, I less than size of rb, I plus plus. If rb I, which is in the for loop, is equal to a, and so on, a, e, I, o, u. There's all the vowels, and I'll convert them to rbi is equal to 2 upper rb I. Next I'll print the receive string. So lastly you return 0. So let's just take a look at the code, how it's compiled. Out. So pipe is created over here. We got the parent process ID, and now we have to enter a string. Let's say I just enter hello. So the vowels which I have is E and O, so they'll be converted into uppercase letter as shown here. And I'll print the child process and parent process ID as well. So the next part is so let's take a look at the code for the next part. So this is the next part of the experiment, which I'm basically just entering the data over here. So first, if id is equal to 0, we will know that pipe is created. Else, if id is not equal to 0, it's not created. So next we get a string. So this is just for writing. So we get a string, enter the string. I use a scanner class to read it. I save it, I put the value in buffer &buf. So I'll open the file. fd is equal to open my pipe. So that's the syntax for open, and I write. So this is the syntax for write. Fd comma buff comma string length buff. Then I close it. So let me just show you how it's done. Let's compile this first. Okay, pipe is not created, but we enter a string. Let's say, so what string? I'll just use hello. So the string is saved in this. So the next part, let's take a look. So this is basically to read it, to open and read whatever we've entered in the previous file. So here I saved in a buffer array character buf. I gave the size 100. So I'll open whatever I've typed. Fd is equal to open my pipe, and int bytes is equal to. So I'll read whatever I've entered. Read. So this is the syntax for read. Read fd comma buff comma size of buff. And next I'll print whatever's inside buffer in pipe as the string whatever I've entered %s comma buff. So buff is the value stored previously. So let me just run this and show you. Once I run this, /a.out, you should get the buffer in the pipe which I've entered previously as shown here. Before enter string hello, so that hello should be printed in this. So that's all for this ninth experiment about pipes. So thank you.